I'm going to use the same demo solution for maps as I was already using for vectors. And I have these people that I've already created. I'm going to put them into map now instead of into a vector. So here I declare myself a map. And when you declare it, it's a template. You have to say a map of what, and that means what is the key and what is the value. So this particular map, I'm going to map integers to person objects. As you know, people have an arbitrary number, so I decided I would happen to use that for the key. I could have used anything I wanted. So here I'm using the square brackets. People, square brackets, some number, and I'm going to actually use the return value from getNum, equals a person object. And I do that twice using the square bracket notation. And then I'll do it once kind of the slow way, if you will. Create another person who's called third fiction. And notice the number 124. It's in between Kate's 123 and someone's 456. Then I create an object of type standard pair. And standard pair is a template that, again, takes two types. It's a pair of int and persons. And so I'm calling it P, and I construct it by passing in an int and a person. And then I can call people.insert and pass that pair in. Well, I think constructing a pair and then calling insert and passing the pair in is way more work than just using the square bracket notation. The same thing happens when you do this. Now, this is fun. I'm going to iterate through the map. So it's available for looking things up. Who is person at 123? Who is the person at 124? But I can also just iterate through it and say, show me the whole map. And when I do that, you'll notice that this notation is just about identical to the way I was going through a vector. I call begin, and begin on a map gives me back an iterator. Oh, this is way, you can understand why I don't want to type with my fingers on the keyboard the types of these iterators. It's an iterator to a map of ints and persons. You don't actually have to type all these characters if you do it, but it's still pretty gnarly, really. This IP is iterator through a vector of person, but especially when you use auto, the code is exactly the same. Call begin. Whatever that is that gives me, that's the iterator I'm using, and I'm going to keep using it, incrementing it as I go, because of course these iterators all have an overload for the increment operator, until I get to the end, so as long as we are not at the end. And then I'm going to dereference the iterator, and you dereference a map iterator the same as you dereference a vector iterator. But a map iterator points to a pair, and the pair has two elements, first and second. So you have a pair of int comma person, first is an int, second is a person. If we had a pair of floats and strings, first would be a float, second would be a string. So here I can just dereference and say, give me first, that's an integer, and you'll notice that the compiler knows that this is a map of ints and persons, and therefore first is an int, while second, and again the compiler already knows this, is a person. So I'm going to call its getName method. And it's a person object, not a person pointer, putting solid objects into this map, so I'm using the dot to get that person object's name. Why don't I let this run down to here? And take a look at the output. Still got the noise turned on in the destructors, so all the copying around of person objects is continuing to happen with map. It's just as copy. Really, the whole standard library is very copy friendly. There are ways to prevent it from copying by creating objects that can only be moved, and you can imagine they'd have performance benefits for large objects. But you'll see that I created this third fiction object on the stack, and then this is the current contents of our map. 123, 124, 456. It's kept sorted internally. You can also see that by taking a look at it over the debugger. Here's our people. There we go. You can see 0, 1, 2. And they were added in the order Kate, someone else, and then third, but it's kept sorted internally. And this is a pretty good way of looking at the contents of your map. If you need to, of course, you can expand out further to take a look at what first and second. You can expand that and work your way through indefinitely. Pretty easy to use. Just throw things in at their individual keys and then print them all out if you want to, and you can see what order they're in. Of course, usually the reason for keeping something in a lookup table is so you can, look things up. So I can show you some couple ways to do that. Here's one that uses the find method. And I'm just going to stop debugging so that you can see the types because I'm using auto again. Find doesn't return an element in the map, a pair, anything like that. It returns an iterator. So found here is an iterator very similar to this iterator, and therefore you use it by dereferencing it. In the case of a map, there can only be one hit for a given key. That's the definition of a map. But there are other collections that have a find method where you could say, now find me the next one, now find me the next one, by calling find repeatedly. Consistency from collection to collection is very important in the standard library. The fact that for the specific case of map you could just return the element itself would kind of mess up people's mental patterns around using the standard library. So these guys return iterators, which you dereference. If you don't want to dereference the iterator, then do it this way. Find returns an iterator, which I dereference, and I get the pair, and I pull out the first, which is the integer, and the second, which is the name. Using the square brackets, looks up the single person object that's at that key, and it's a solid person object, and I just call its .name method to print out the name. I'm putting it in a string here just to show you that you can do more with things than just print them out. Of course, then I turn around and print it out, forgive me. So let's run down to here so you can see the output. Actually, let's turn off this constructing, destructing noise. I think the point is probably taken that, yeah, there's a lot of copying, there's a lot of constructing and destructing going on. So we'll run. Just take a quick glance at the output. This part comes from just filling up the map and iterating through it. And then we have the two finds. And they print out 123 Kate Gregory, person at 124 is third fiction, and that makes sense looking through the code. 124 was third fiction, and 123 is Kate Gregory. So either way, you want to work with a map, using the find method, making your own pairs and calling insert, or just using the square brackets. It does it, it takes care of it for you. If it needs to get bigger because you just added another item, it makes itself bigger, copies everything over, deletes all the old ones. People don't expect C++ to just take care of stuff for you. They expect it to be hard, but the standard library is actually set up not to be hard at all. This is a really easy way to just keep track of stuff for me. My objects are small. I'm done. I've found the collection I need. If your objects ever aren't small, you can drill in to try to find other collections that perhaps work more efficiently for you.